aka IAM Roles and Policies. So basically, introduction about AWS offers a range of tools that enables developers and administrators to manage cloud resources programmatically. CLI, which stands for the Command Line Interface, and SDK stands for Software Development Kits. So this allows the users to automate tasks, deployment, and integrate AWS into applications. IAM, which is called as Identity and Access Management, provides fine-grained access control to securely manage permissions. Programmatic access, ideal for CI and CD pipelines, infrastructure as code, and scalable cloud operations. AWS CLI overview. The AWS command line interface is a powerful tool that enables users to manage and interact with AWS services through a simple command line commands. It provides a consistent way to automate tasks, configure resources, and perform operations without using the AWS management consoles. Configuration. To start using the AWS CLI, you need to configure it by running the command line AWS configure. This process set up the essential credentials and preferences that allow the CLI to authenticate and communicate securely with your AWS account. Access key ID and secret access key. These are your AWS security credentials that verify your identity and grant permissions to perform actions. Default region specifies the AWS region where your commands will be executed by default. Example, US East 1 or EU West 2. This saves you from specifying the region in every command. Output format determines how the CLI displays results. Option includes JSON, text or table format, helping you choose the best way for your need. AWS SDK overview. AWS software development kits provide libraries in multiple programming languages, enabling developers to interact with AWS services programmatically through APIs. This SDK simplifies the integration of AWS resources into applications by handling low-level details like authentication, retries, and request formatting. Programmatic access. SDKs allows developers to perform operations on AWS services directly from their code, enabling seamless automation, custom workflows, and scalable backend logic. Use cases of the SDKs are like integrating AWS with web or mobile applications, automating infrastructure tasks within application code, handling complex logic like file uploads, data processing, and event handlings. Supported language. AWS SDKs are available for popular languages such as Python, Java, JavaScript, Node.js, Net, Ruby, and more, making it easy to build applications across diverse environments. Example, using Boto 3, which is like a Python SDK, you can upload a file to Amazon S3 with just a few lines of code, streamlining storage operations within your app. IAM, which is called as Identity and Access Management, is a critical services that helps you securely control access to AWS resources. It enables you to define who can access which source and what actions they are allowed to perform. By managing permissions precisely, IAM helps protect your cloud environment from unauthorized access and potential security risks. Key components. IAM consists of several building blocks that work together to create a flexible and secure permissions. User. This represent individual people or service icon that need AWS access, each having unique credentials like password or access key. Group, which is a collection of users that shares common permissions, making it easier to assign and manage access right collectively. Roles. So special identities that can be assumed temporarily by users, applications, or AWS services, granting them specific permissions without sharing long-term credentials. Policies written in JSON. Policies define detailed permissions specifying which actions are allowed or denied on the AWS resources. Manages access. IAM governs access permissions across all AWS services and resources, ensuring only authorized users and applications can perform specific operations. Security model. IAM follows the least privilege principle, meaning users and services receive only the minimum permissions necessary to complete their task, reducing security risk and exposure. IAM roles. IAM roles provides temporarily a secure credential that AWS services and users can assume to perform specific tasks without needing long-term access keys. Role enhance security by minimizing credential exposure and enabling flexible permissions management. Temporary credentials. Roles issue short-lived credentials that automatically expire, reducing the risk of compressed keys. Common use cases. Roles are frequently used with services like EC2 instances, AWS Lambda functions, and for cross accounts access to security grant permissions without sharing the credentials. Trust policy. Each role has a trust policy that specifies which user, services, or account are allowed to assume the role, ensuring a strict control over role usage. IAM policies. IAM policies are JSON formatted document that define permissions for AWS users, groups, and roles. They specify what actions are allowed or denied on specific AWS resources, forming the foundation of AWS access control. JSON-based permission sets. Policies are written in a JSON syntax, detailing allowed or denied actions, resources, and conditions for access. Types of policies. Inline policies and managed policies. Inline policies are directly attached to a single user or else group or a role and existing only within that entity, whereas the managed policies are standalone policy that can be attached to a multiple user or groups or roles, making them easier to manage and reuse. Example, a common policy grants full access to the Amazon S3, allowing all S3 actions on all buckets and objects. IAM best practices. To maintain a secure and well-managed AWS environment, it's important to follow key IAM best practices that help reduce risk and improve access control. Enable multiple factor authentication, which is called MFA. Add an extra layer of security by requiring a second form of verification like a mobile app or a hardware token for user sign-ins. Use IAM roles for application. Instead of assigning long-term credentials to user or apps, use IAM roles to grant temporary permissions to AWS services like EC2 or Lambda. Review policies regularly. Periodically audit and refine IAM policies to ensure user and roles have only the necessary permissions, nothing more. Monitor with IAM Access Analyzer. Using IAM Access Analyzer to identify and review resources that are accessible from outside your AWS account, helping detect unintended exposures. Thank you so much.